Hi, welcome to ArkIntel. Imagine a place so cold, so distant, and so hostile that a ripped glove could be a death sentence. Now imagine building a future there. That place is Mars. While the headlines keep flashing about missions, moon landings, and billionaires plotting interplanetary leaps, what's really at stake? And how close are we to sending humans to another planet for real? Today, we are diving into the truth behind the Mars missions, what's driving it, what's stopping it, and why the clock may already be ticking. Let's expose what's really going on. Tucked away in the Utah desert lies a strange outpost, a simulation site designed to mimic Mars. Known as the Mars Desert Research Station, this location serves as a trial ground for life on another planet. Volunteers run mock missions, scan rocks, simulate data transfers, and study how a human crew might survive. Even Elon Musk has poured more than $100,000 into this operation through the Mars Society. But make no mistake, this is still Earth. The real thing? Far more unforgiving. Musk has declared that his company, SpaceX, could land people on Mars by 2029. Meanwhile, NASA is aiming for a more conservative, some say realistic, target sometime around 2040. And China, they are eyeing a robotic base for their own by 2038. Why the rush? And what makes this world so important? According to Elon Musk, the future of civilization depends on it. He argues that spreading life beyond our own planet is essential to surviving catastrophic events, whether natural or man-made. Scientists too have their reasons. Mars and Earth were once eerily similar: rocky terrain, flowing water, and thick CO2 atmospheres. If life began on Earth under these conditions, it might have also sparked on Mars. But did it? If so, how? Was it the same path or a completely different origin story? Beyond the search for alien microbes, space technology developed for Mars has already changed life here. From advanced pharmaceuticals to lighter aircraft materials to better batteries, we've seen space-driven innovation ripple across industries. Yet, despite the breakthroughs, a Pew Research survey found that only 11% of Americans think crewed Mars missions should be NASA's top priority. Most want to focus on Earth, monitoring climate change or tracking dangerous near-Earth objects. There's also the issue of cost. Sending humans to Mars? Experts peg the price tag at nearly $500 billion. That's more than double the cost of either Apollo, the Space Shuttle, or the International Space Station. It could even match the cost of all three combined. And that's just for one mission. NASA's current budget for 2025 is about $25 billion. That's less than 1% of the federal budget, and it's at risk of shrinking. The Trump administration has proposed cutting $6 billion from NASA by 2026. The cuts would hit key areas like Earth science, support systems, and space research. But at the same time, they are pushing $7 billion towards moon exploration and injecting another $1 billion into Mars program. NASA may be learning to do more with less, but to reach Mars, they will need to do more with more. NASA is increasingly outsourcing to private companies, most notably SpaceX. But the business case for Mars isn't exactly ironclad. Right now, most revenue for space firms comes from government deals. There is little commercial incentive to land on a planet with no customers. Still, past investments in space have yielded unexpected returns. GPS, satellite internet, even LASIK eye surgery all born from space technology. Heart pumps and water filters used in homes today were first developed for astronauts. The challenge ahead isn't just scientific, it's logistical. Getting to Mars isn't like going to the moon. It's like trekking to the bottom of the ocean during a hurricane with no backup. The average distance to Mars is about 140 million miles, nearly 600 times farther than the moon. A round-trip mission would last about 3 years. By comparison, a moon trip takes just 3 days. The longest any astronaut has ever stayed in space continuously is 371 days. Frank Rubio aboard the ISS. A Mars mission would require nearly triple that. At the heart of Musk's plan is the Starship rocket. When fully assembled with its super heavy booster, it stands 403 feet tall, capable of hauling up to 150 metric tons into orbit. But there's a catch. In March, during its 8th test flight, Starship's booster landed safely, but the spacecraft itself exploded mid-flight. The timeline? SpaceX wants to send a robotic version by 2026 and humans 2 years after. Experts say that's wildly unrealistic. Another hurdle: refueling in space. Starship is meant to launch with no fuel, then refuel in orbits before heading to Mars. But this has never been done. Some experts propose alternatives, like building a smaller starboard that launches fully fueled bypassing mid-space refueling. Others suggest leveraging the tried and tested Falcon 9 instead. NASA's Artemis program was meant to return humans to the moon as a stepping stone to Mars. But under the new budget, key parts of that plan may be scrapped: Space Launch System, Orion capsule, and the Lunar Gateway Station. Also at risk is the Mars Sample Return program, which aimed to bring Martian rocks back to Earth. Musk has long criticized Artemis, calling it inefficient. NASA's Inspector General estimated Artemis would cost $93 billion from 2012 through 2025. Musk, meanwhile, is gaining influence. He led a government initiative aimed at slashing federal spending, especially in agencies that regulate his companies. He's also spent nearly $300 million backing Trump's re-election bid. Trump's nominee to run NASA, Jared Isaacman, has personal ties to Musk. He's funded multiple private flights with SpaceX and leads a payments company partnered with Starlink. Isaacman claims his loyalty lies with the nation, but critics worry about the conflicts of interest, especially as he supports dual missions to the moon and Mars, exactly what Musk wants. Let's say we actually land humans on Mars. What then? Mars isn't just cold, it's lethal. Temperatures can plunge to minus 225 degrees Fahrenheit. Its atmosphere is 1% as dense as Earth's, composed mostly of carbon dioxide. One tear in a spacesuit could be fatal. The soil contains perchlorates, chemicals toxic to humans, and Mars' gravity is too weak to keep muscles and bones healthy over time. Exercise can help fight muscle loss, but radiation is the real killer. Unlike Earth, Mars has no magnetic field to shield against galactic cosmic rays. Protection would require materials like tungsten, too heavy and expensive for current spacecraft. Long-term exposure can cause cancer, impair vision, and potentially lead to blindness. Astronauts on long missions already report eye changes and cardiovascular issues. And then there is isolation. Years of confinement in cramped quarters with 40-minute delays in communication would push even the most stable minds to their limits. A Mars crew wouldn't have the backup supplies or resupply missions like the ISS. They would need to grow their own food, something crews are already testing on Earth. At the Utah simulation site, they've grown tomatoes, radishes, carrots, and attempted mushrooms, but conditions were too dry. Electricity would come from solar panels and propane generators. But Mars is known for massive dust storms that can block sunlight for weeks. That's why many experts say nuclear power, still in its early stages, may be the only dependable solution. And if astronauts want to come home, they will need to make their own fuel, something never done before. The plan is to convert Martian water and CO2 into methane and oxygen. Conveniently, that's the same fuel Starship uses. While the dream of reaching Mars captures our imagination, the sheer scale of this endeavor brings a crucial question into focus. Experts estimate that a single human mission could require upwards of 100 Starship launches, a monumental undertaking of resources and energy. A realistic timeline for boots on Martian soil likely stretches well into the latter half of this century. And while the spirit of ambition, of pushing boundaries, is deeply ingrained in humanity, we must confront a more immediate challenge: the health of our own planet. The resources, innovation, and collaborative spirit required to reach Mars pale in comparison to the urgent need to safeguard Earth, our only known home. Instead of solely focusing on escaping potential futures, perhaps our greatest endeavor lies in building a sustainable present. The ingenuity that fuels our Martian aspirations could be powerfully redirected towards solving climate change, preserving biodiversity, and ensuring a thriving Earth for generations to come. The dream of expansion shouldn't overshadow the responsibility of stewardship. Ultimately, proving humanity's ability to rise might not be about reaching another planet, but about demonstrating our capacity to heal and protect the one that sustains us. If you found this video thought-provoking, make sure to check out The Climate Crisis is Real. In this video, we reveal the shocking truth about discounting, a hidden formula used in climate policy that's putting a price tag on future lives and justifying inaction on climate change. We exposed how this mathematical trick devalues future generations and allows governments and corporations to prioritize short-term profits over long-term survival. Click the video to watch now.